On this 2015 to 2025 F150 with the 2.7 EcoBoost, P0521 generally means the oil pressure signal may not look believable to the PCM. The truck may have an oil pressure warning, a check engine light, or it may not show much of a drivability complaint at all. Broadly, this can involve oil level or oil condition, the oil pressure sensing circuit, connector or wiring issues, possible power or ground problems, and in some cases, a mechanical oil pressure concern. The key is not to jump straight to a part. Start by proving the concern is present and then work the basic checks in order. Before getting deep into testing, do the obvious checks. Look for anything that lines up with the customer complaint. Check for any available Ford service messages or bulletins, and look for previous repair work. A repair that was done incorrectly can absolutely create the next complaint. Also make sure the battery and charging system are healthy, and verify battery SOC is greater than 70% before starting diagnostics. Next, scan all network modules for codes that relate to the concern. If other codes are present, use them to decide where to start. Circuit-related codes come before system or performance-type codes. If there are several circuit faults at the same time, slow down and look for a shared cause, like a common power feed or ground path, before chasing each fault separately. Now do the broad physical inspection before narrowing in on the oil pressure signal. Inspect harnesses for damage, chafing, and routing problems. Check fuses, circuits, and connectors for continuity and correct installation, and make sure the related components are fully connected. Then continue the basic sweep. Inspect vacuum lines and the air intake for leaks, routing problems, or restrictions. Inspect hoses for damage, leaks, blockage, and routing. Check fuel quality for octane, contamination, and seasonal blend. Inspect the fuel tank and fuel lines for damage, leaks, and routing. Check coolant level and quality with the engine at the correct operating temperature. Check engine oil level and oil quality for contamination or maintenance issues. And inspect the exhaust for damage, restrictions, and routing. For this code, the oil and electrical checks are the pieces that usually drive the next diagnostic decision. But the rest of the sweep helps keep you from missing an obvious related concern. When you connect test equipment or jumper leads at connector pins, use the proper flex probes or terminal probe kit so you do not spread or damage terminals. Check male to female terminal fit with the mating pin. A damaged pin will have very low separation force. If a small terminal has to be checked correctly, remove it from the connector shell, guide, or retainer if that extra plastic is adding drag. Damaged connectors, pins, or terminals get repaired by replacing the damaged connector, pin, or terminal. Use the scan tool to read PID inputs, output states, and diagnostic states. Monitor the data in the data logger so you can see the signal behavior without unnecessary disassembly. If module behavior is part of the question, understand how the module is supposed to operate, make sure programmable parameters are correct. Handle the DTC path first, test inputs, test outputs as needed, and check for module software updates. If you use output state control, use it to prove the module can switch an output on and off, then go back and analyze the inputs. Do not apply power or ground directly to module switch components unless a directed test tells you to do that. When you are checking a power providing circuit, do not trust an unloaded voltage reading with the load disconnected. That usually only finds an open, like an open fuse or open circuit. For circuits carrying approximately 200-1000 mA, load the circuit with a 250-350 M, a test light, and measure voltage with the DMM while the light is connected. For 24-gauge, 0.5 mm, or smaller conductors that generally carry approximately 1000 mA, 1 ampere or less, that same 250-350 M, a test light is the intended load. For circuits carrying more than 1 ampere, use a load that draws similar current like a brake light bulb. Conductor sizes 20-gauge, 0.8 mm or larger are generally used to carry 1 ampere, 1000 mA or more. A voltage reduction while the circuit is loaded points to excessive resistance. For higher current circuits, voltage drop is the better test. For ground-providing circuits, measure voltage drop while the component is operating or at least attempting to operate. Only use an ohmmeter on ground circuits with the battery disconnected. For most small diameter 18-gauge and smaller wires, expect less than 2 ohms. For most wiring harness circuits, also expect less than 2 ohms, but stay within what a standard DMM ohmmeter can accurately show. Its low resistance resolution is approximately 0.1 ohm, and that limits its accurate use to circuits carrying less than approximately 5 amperes. Above that, use voltage drop testing. Reverse the DMM leads and check the reading again. Unless the circuit contains a semiconductor, the resistance reading should not change. For unintended continuity to ground or between unpowered circuits, disconnect both ends and expect greater than 10,000 ohms. For unintended continuity to a powered circuit, disconnect both ends, turn ignition/run power on, and expect no voltage. Back probing has its place, but it is risky because the probe contact may be uncertain and the terminal can be damaged. Use it only when the circuit has to be tested under real operating conditions, when voltage drop has to be measured, or when opening the circuit could change module behavior. In voltage drop testing, expect a small amount of voltage, less than 5% of circuit operating voltage. A 0-volt result means the test setup is wrong. The circuit is not flowing current, or the back probe connection is bad. Do not use back probing for a single-point voltage check, where 0 volts could be a valid result, and do not use it for ohmmeter continuity or open circuit checks between 2 points. Disconnect and isolate the circuit for those tests. If jumper wires are used, always use fuse jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less. Do not use flex probes to carry high current greater than 5 amperes, and do not use them to power high current devices. Follow the directed jumper setup carefully, and never repair a circuit by simply adding a parallel wire without finding why the original circuit failed. For voltage drop, connect the voltmeter at the beginning and end of the suspect circuit, with the circuit powered and operating or attempting to operate. Follow conventional current flow for lead polarity. A 0-volt reading points to bad voltmeter connections or the component not being turned on. A small reading is normal circuit loss. In 12-volt circuits, that is usually less than 0.5 volts or less than 5% of circuit operating voltage. More than 0.5 volts indicates abnormal voltage loss from high resistance in wiring or connectors. For voltage in voltage out testing, put the negative meter lead to ground or battery negative, then measure the power side and ground side of the load while the circuit is operating. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts but less than 0.5 volts. A reading of 0 volts or source voltage indicates an open circuit. One important boundary on this episode. This path does not provide a P0521 specific pinpoint chart, monitor formula, component-specific wiring branch, or confirmed repair. So if your testing reaches a point where that missing detail is needed, pause, recheck the earlier diagnostic path, and avoid guessing. After any correction, keep verification separate from testing. Run the vehicle under the conditions that reproduce the concern. Then verify the repair and confirm the code stays gone. The takeaway is simple. Prove the concern, check oil condition and the signal circuit basics, load test the wiring correctly, and do not condemn parts without a valid test path. For more diagnostic training, visit stepdiagnostics.com.